we have a question that asks us which of the following tables represent a probability distribution function. Give your reason. Okay, so let's go through the first table here. So we've got x is equal to 1, or is equal to 2, or is equal to 3, or is equal to 4. And then we have the probability of our variable is equal to the value of x. So what's the probability that it's equal to 1? In this case, it says it's 0.2. All right, 20%. And in the next one, it says it's 0.2. And the next one, it says it's 0.3. And the next one, it's 0.2. So this table could be saying something like there's 4 bands of students. There's the lowest grade, second grade, third grade, and then the best grade. And then the probability that a student is placed in between those ones. So to make it a probability density function, there's a couple of things we need to do. First of all, is that everything needs to add up to 100%. Okay? So you might see like a fancy equation like this, that the sum of x is equal to, I don't know, n to infinity of the probability of x is equal to x must equal to 1. Okay, that's just saying like if you add all of them up, they should be equal to 100%. So let's try that, right? Let's try that. So, well, we've got a calculator, so let's use that. So 0.2 plus 0.2 plus 0.3 plus 0.2. Huh, not quite. It's only equal to 90%. So we're not quite there. All right. So if we sum them all up, so 0.2 plus 0.2 plus 0.3 plus 0.2 is equal to 0.9. And then you just have to say plain English. So table 1 is not a prob density function. And if you want to save on space, you can say PDF is not a PDF as the sum is not equal to 100%. Oh, there you go. That's 1 mark. It's probably a bit wordy, but I just wanted to go through in detail what everything means. Let's go to the next table. Table 2. So we've got x here. We've got x can equal to 5, or it can equal to 6, or it can equal to 7, or it can equal to 8. And we say that the probability of some variable called capital X, when that's equal to x, is going to be equal to 0.2, 0.4, 0.5, and minus 0.1. Hey, here's another rule. You just can't have a negative probability. What does that even mean? What does it mean you've got like a negative 30% chance of winning the lotto? That doesn't make any sense. So you can say table 2 is not a PDF as the probability of x is equal to 8 is negative. And that is not allowed. Cool, let's go on to the third table. Okay, so table number 3, and we have some variable x that can either be equal to 0, 1, or 2, and the random variable, capital X, can be equal to that value. All right, so when the capital X is equal to 0, there's a 30% chance, there's a 40% chance, and then there's a 30% chance there. So we say sum of probabilities is 100%, and no negative values. This is a PDF. Table 3 is a PDF. All right, is a probability distribution function. Cool. Then we've got this last table here. So table 4 And we've got x there. X need to be equal to 10, 20, 30, or 40. And again, the probability can either be equal to that 0.3, so 30%. Here we go. Or 110%. There we go. So hopefully you see straight away, not a PDF as sum of probabilities does not equal to 100%. There you go. 4 tables, 4 marks. Use your calculator to add everything up. It's a lot easier that way. If you have any questions, leave a comment, email me. I'll be happy to help. I've got plenty of other questions like this on my website to help you get as most marks in your test as possible. So check it out. Link is in the description. See you in the next video.